We're in 13.4 problem solving with trigonometry. There's only two things we really need to cover in this lesson. The first is the area formula, and the second is working in the coordinate plane. As far as the area formula goes, it's actually pretty simple. It's given right here. And they give it 3 different times. So let's look at their triangle real quick. They have triangle ABC with a capital A, capital B, and capital C representing the vertices. And then they have a lowercase a, lowercase b, and lowercase c representing the sides. Note here that the lowercase a is always opposite the angle A. And the lowercase side b here is opposite angle B. Side C is opposite angle C. And what these 3 formulas do is they basically let you use any of these 3 angles to calculate the area, right? There's nothing special about any particular orientation for a triangle, so any of these would work. But what they do is they take 1/2 of one side. Say we'll do this first one. 1/2 B times C, so 1/2 side B times side C times the sine of angle A. So the sine of angle A. And note here, angle A is the included angle between those 2 sides. If for whatever reason we relabel these or don't have these values, we could use any of these other areas formula, but they're the same thing. They're 1/2 side, and the sine of the included angle, all multiplied together. So we'll show this in action here. We have our triangle here. We have 2 side lengths that are known, and we have the included angle. And this is really powerful because now we don't need a right triangle. Before, when we calculated area, we needed a right triangle, but now we don't. All we need to do is plug in 3.2, 4.7, the sine of 142, and 1/2, all into just multiply them all together, and it should spit out the answer. So we'll see if that works here real quick. Help me out here. We got 3.2, and we'll multiply that by, what are the other values? 4.7 times 1/2 times the sine of 142. 142. Note here we're in degrees, not radians, and that spits out 4.63 or 4.6. So let's see what they got. They got also 4.6. So again, you just plug these into the formula. There's a lot of pieces to plug in. There's 3 whole pieces, but it's pretty formulaic. We'll do another example here. Part B here says we have triangle DEF. This one, it doesn't give us a picture. So it says DE is equal to 9, DF is equal to 13, and angle D is 57. Well, before we plug these in, we have to check, is angle D the included angle? All right. What do we think? Is it the included angle? Pause. Yep, as it turns out, it is the included angle if you draw a little picture. So since it is the included angle, we are in the formula. So that gives us the area formula is 1/2 times a side, in this case DE, times the other side, DF, times the sine of the included angle. We can plug all these values in, so that gives us 1/2 of 9 times 13 times sine of 57. Again, plug and chug. Mr. Calculator will give you an answer of about 49.1. So I'll let you go ahead and try this one really quick. We'll do another pause. Whoa. Hopefully you got an answer of about 50.3. 1/2 12 times 15 times the sine of 34. If you're getting weird answers, again, check, make sure you're in degrees, not radians. Okay. For the second part here, we'll be solving in the coordinate plane right triangles. If you're comfortable working in the coordinate plane, if you can do distance formula and check slopes and angles, then don't worry about this stuff. You should just be able to breeze right along. But if you want a little bit review, stay tuned. And we'll go through one of these guys together. So they say triangle A has these vertices. We can just scroll down to have it be graphed automatically. So it looks something like this. We have triangle A, B, and C. It says find all the side lengths and angle measurements. So we just need to solve it. The two easy sides to do are AB and BC, right? We can just count those. It doesn't take too much brain power. That's 1, 2, 3, 4 for AB, and 1, 2, 3, 4, 5, 6, 7 for BC. So these guys should be relatively quick because they're straight up and down, left and right. To get AC, the book uses the distance formula. Again, though, I would just use Pythagorean theorem, or I mean, you can count, but we just did. So this is essentially 7 squared plus 4 squared, right? That's 49 plus 16, which is 65. So the square root of 65 is about 8.06. So I can label it on here, I guess. 8.06. Finally, we need to find the angles, right? So the first thing is to check the 90-degree angle. Do we have a 90-degree angle? Well, AB is vertical, BC is horizontal, therefore these are perpendicular, and we have a 90-degree angle there. And then we can find angle C or angle A. It's up to you which one you want to find. The book, again, does things a little bit differently. They like to be difficult sometimes. Oops. So get this further down here. So I would suggest using, when you calculate these angles, to avoid this one, because this is a rounded value. If you use AB and BC, then you'll get more exact values. So I would use tangent. The book finds angle C, and we can work with that. The book just skips ahead to this step here. Again, I like to just set up the problem, solve it algebraically, and then go from there. So really, how it gets here is to say that the tangent of angle C, so I'm going to put tangent of angle C, is equal to, in this case, tangent is opposite over adjacent, so that's 4 over 7. I'm going to put over here on the right, that 4 over 7. In order to solve for angle C, I take the inverse tangent of both sides, so that gives me inverse tangent of that, inverse tangent of this. These, the inverse tangent and the tangent cancel, leaving me with just angle C. And so basically C is equal to, or angle C, the inverse tangent of 4 over 7, which is what the book came up with here. We can check this in our calculator with the inverse tangent of 4 divided by 7, and that gives us 29.7, which the book rounds up to 30 degrees. If angle C is 30, then angle A is 60. So that's where we get those values. Let's try another. We have triangle DEF. So D to E to F. This guy's going to be trickier because we have no vertical or horizontal lines. So we may actually have to use the distance formula here a couple times. Let's start with DF. So DF is down 2 over 3. Again, I would eschew the distance formula for just counting and using Pythagorean theorem. So this is a 3, 4, 5 triangle, right? So DF should be 5. What? Oh, I forgot to do that thing. Okay, never mind. I got ahead of myself. We're down here. DF is 5. FE, we also do need to calculate FE. Sorry, I got mixed up. FE is 1, 2, 3, up 4, 1, 2, 3, 4. So this is also a 3, 4, 5 triangle. So we're going to go down here, down at the bottom, sorry. And the calculation for EF is that it's 5 units long. We'll get back to that in a second. And finally, we have DE. We have D to E. So again, that's 1 unit up. 1, 2, 3, 4, 5, 6, 7. Up 1 unit over 7. So we can use Pythagorean theorem or distance formula for that. So that is, where is that? So that means 1 squared plus 7 squared, or 49 plus 1 is 50. The square root of 50, which they calculate out to be about 7.07. So we can label that on here. Might as well, I guess. This is 7.07 units long. And these are 5 each. 5. That's 5. The part I skipped here, which I'll come back to, is the slopes. We need to identify the 90-degree angle. So just with a cursory observation, we can say, oh, the one that's probably 90 degrees, the widest one, is angle F. So let's, before we really start this whole thing, we should probably check that it's a 90 degree angle, that it's a right triangle. So angle F here, we have to check that by comparing the slopes of DF and FE. If the slopes of DF and FE are opposite reciprocals, then that means they're perpendicular and it's a 90-degree angle. So DF is down 3 over 4, or negative 3/4. What do you think the slope of FE is? Well, you guessed it, it's 4 over 3. They're opposite reciprocals. Therefore, we can say that with certainty that this is a 90-degree angle, and we can do all our right triangle shenanigans on this, including right triangle shenanigans allowing us to calculate angle D and angle FE. Again, we can potentially do a shortcut here. But we'll do it the way the book does it for starters. So the way the book does is they're like, oh, let's use sine. So I say, sure, why not? Let's humor them. We'll use sine. They're basically using sine and angle D. So angle D is up here. They're saying that, again, this is my way of setting it up, because I like to set up the whole thing. I like to say that the sine of D is equal to, sine is opposite over hypotenuse, or 5 over 7.07. And then we take the inverse sine of both sides. So there's the inverse sine. Inverse sine. These ones canceled, and we're just left with D equals the inverse sine of 5 over 7.07. The reason why they didn't use 5 over 5 is because it's much too obvious. Once you realize that there are 2 5s here, you should realize that you can skip this whole trig step, actually, as it turns out, because what type of right triangle is this? Well, if this side is 5 and this side is 5, those are congruent sides. Therefore, these angles are congruent. Therefore, it's an isosceles. And you can figure out that both angles are 45 degrees. So, because that was relatively easy to figure out. But we could have solved it the hard way if it was required. Okay, we have this triangle here. This is triangle JKL. Again, none of these are vertical, none of these are horizontal. Go ahead and check to make sure that angle J is a right angle. Spoiler alert, it is, but you should be able to prove it, right? And then do the side lengths, I think. Side lengths will be next. So I'll pause here. Okay, you should have gotten these side lengths. Once you get these side lengths, using pretty much just the distance formula a couple times, you should be equipped to figure out the missing pair of angles here. This one you will have to do a little bit of trig for. Again, I'll pause. And our final value should be somewhere along the lines of 34 degrees or 66 degrees for those two angles respectively. Sorry, different problems. It should be 1 through 10. Yep, 2, 10. Okay, see you guys later.